We're going to talk now about the permaculture sectors and at the same time examine two of our permaculture principles. Sectors are directional forces coming into a site from the outside. We map sectors so we can see what the major influences are on the site that are coming towards us, and then our design becomes a response to those forces. I'll provide an example. Here we have a house. In the temperate climate zone, where day length and the angle of the sun changes throughout the year. In the wintertime, when it's colder, that sun is a precious commodity. When the atmosphere is clear, solar energy is a renewable resource that can help to heat a structure, providing free lighting, produce electricity, and provide light and heat for plants. So here we have the winter sunrise, we have the sun moving low through the sky, we have the winter sunset, and that angle is low and it's hitting the structure. Here I've drawn a greenhouse and some solar panels to take advantage of that sun angle in the winter. So from the home, my design response to this winter sun sector is to leave a pie slice open and free of tall trees, buildings, or other obstructions in order to welcome the sun at the times that I most need the energy. So this is where my design is using the principle of use and value renewable resources and services. I am valuing the solar sector, both in the orientation of the structure to face the light, as well as the placement of other elements that will benefit from maximum light and heat that comes when the sun's low in the wintertime. The sun is a renewable source of energy, and especially in the temperate climate, orientation towards the sun is a key design pattern. Oftentimes in a temperate climate, cold winds will come from the direction of the poles. So in my diagram here, I will draw the cold winter winds sector. Where I wanted to be open to and welcome the winter sun from one direction, that's not the response that I want to have to the winter winds. I actually want to block or deflect those winds. So in the pole side of my structure, I want to plant some trees that will have a mass during the winter month. So I'll put some nice, dense, evergreen trees so the wind does not blow at full force right up against the back side of the house. Now, maybe I want to block the rising summer sun coming in due east. So let's look at the summer sun sector for a minute. So now we got the sun rising in the east, and the trees will keep the house cooler during the hottest times of the year. So these nice deciduous shade trees will lose their leaves in the wintertime and still allow that light access on this side, but in the summertime, they will shade the house from the east. And maybe there's a big, ugly industrial area due west that makes lots of noise and drifts in bad odors when the wind comes from that way, and I also don't want to see that out of my window. So I plant a dense hedgerow of evergreen shrubs and trees to the west, which also block the hot setting sun from hitting the house during summertime. You see, there are elements in my design that are directly responding in some way to the sector forces. So this is an example from the temperate climate. And now I'm going to draw another example from the tropics. Closer to the equator, where the length of the day doesn't change much, nor does the angle of the sun change dramatically throughout the year, structures are not oriented towards the sun like we have in the temperate climate, but they're typically oriented towards a different sector, which is cooling winds. So this here is a slope site with a forest up off-site on the hillside. This site is located in the wet-dry tropics, meaning there is both a wet and a dry season. This means that during the dry season, along with the prevailing winds blowing upslope in this example, we also have another very important sector force to consider, and that is fire. Now, what happens when we have a major change in this situation? Let's say, for example, that this upper hillside right here is not under our control and gets logged or denuded of vegetation in a fire, and suddenly a once lush and water-absorbing landscape full of all different species and great diversity is now a barren, water-shedding landscape. So suddenly, we have this whole other force to consider, and that's the erosive power of water flowing down a slope during heavy rains. So this brings us to our other permaculture principle for this lesson: creatively use and respond to change. This is actually a common situation. Whenever I visit a site that's downhill or downstream from forested land, I always want to find out what the land ownership is in the upper watershed, and if it's expected to be logged, developed, or altered in some significant way. I have actually seen this situation again and again and again. So how can we turn this very common problem into a solution? How can we creatively use and respond to this change? So here's my little brainstorm on this diagram. Basically is to create these off-contour swales that soak in the surface water flow, then divert the overflow around the central house area into this pond that then spills over into production terraces. Now, this will help to accentuate the cooling force of the wind in the house as the breeze blows over the water, and also puts a pond and irrigated beds between the house and this fire sector right here. So now we've used at least 2 permaculture principles in order to respond to our sector forces. This is the type of thought process that we're hoping to convey when we use the sector compass tool as a design method. And I hope that you can see how important it is to really take your time to assess your sectors as part of the overall process for the permaculture design of a site.